This is the Unit 5 review, also known as the second part of Unit 4. This lesson will focus on writing and balancing formula equations and predicting reaction products. In the first 6 exercises, the objective was to balance the formula equation and identify the reaction type. What I like to do first is I like to compose an atom inventory, the number and types of atoms present on both sides. There's 1 silver, 1 nitrogen, there are 3 oxygens, and 1 nickel on the reactant side. On the product, the same order, 1 silver, nitrogen, it appears there are 2. Oxygen, you have 2 times 3, there are 6 oxygens, and 1 nickel. Okay, so the first thing I would do to balance this, I would put a 2 in front of the nitrogen. So I need 2 silver nitrates. That's going to make this 2. Silver is also 2. Oxygen 2 times 3 is now 6. It looks like we fixed the nitrogen and the oxygen. We need to have 2 silver. Put a coefficient 2 here. Now that is a balanced formula equation. I look at what type of reaction this is. Basically what you notice is that I have the nickel taking the place of silver. And so this would be a single replacement. In this problem we have aluminum reacting with bromine. Notice bromine is diatomic, thus the Br2. It's one of the go to 7, make a 7. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and their goofy friend hydrogen. Or, you know, if you prefer the Brinkelhoff twins, that's fine. But bromine, definitely a diatomic element. You'll notice that they react to form aluminum bromide. And that is the correct formula for aluminum bromide. Aluminum has a 3+ charge, bromine is 1-, so it's AlBr3. How do we fix this? Well, let's see, we've got 1 aluminum and 2 bromines. On this side, 1 aluminum and 3 bromines. So I look at a common factor between 2 and 3, it's 6. So if I place a 2 here, there are 6 bromines now. If I place a 3 here, this will make 6 bromines. Then I have to balance the aluminum. This was 2, this one becomes 2, and we have a balanced reaction. You'll notice in this instance I have 2 elements that are combining to form 1 compound. So this type of reaction is a synthesis reaction. Or you may call it a composition, either one. But synthesis, 2 things becoming 1. Alright, in this reaction it looks like we have aluminum sulfate reacting with water to yield aluminum hydroxide, and then H2SO4 is sulfuric acid. Let's do our atom inventory. Okay, it looks like I have 2 aluminum. There are 3 sulfurs. Oxygen, I have 3 times 4, which is 12, plus that 1 in the water. So I have 13 oxygens and 2 hydrogens on the reactant side. On the product side, there is 1 aluminum. Sulfur, I have only 1. Oxygen, I have 3, and then plus 4, I have a total of 7. Hydrogen, I've got 3 and 2, I have 5 hydrogen. Okay, taking a look at this, I may start by putting a 2 in front of the aluminum hydroxide to balance the aluminum. Now I have 2 aluminum. The oxygen now, 3 times 2 is 6, plus those 4, I now have 10 oxygen. Hydrogen, 3 times 2, I have 6, plus those 2, I now have 8. Alright, let's look at sulfur. I have 3 and I have 1. So if I put a coefficient of 3 in front of the sulfuric acid, the sulfur is now going to be 3. Hydrogen, I have those 6 plus 6 from the other compound, so now I have a total of 12 hydrogen. And then oxygen, 3 times 4, there are 12, plus those 6, I have a total of 18 at this point. Alright, looking at the oxygen, I have 13 and I have 18. I don't have a fun factor number that both those numbers go into, so I'm going to skip it for now. I'm going to go down to the hydrogen. Noticing I have 2 on the reactant side, 12 on the product. An easy way to do that is if I put a coefficient of 6 in front of the water, that's going to give me 12 hydrogen. The oxygen, now I have 12 plus 6, lo and behold that's 18, and without even trying we balance the oxygen. And so that would be the balanced formula equation. Now I have to determine what type of reaction this is. Okay, notice I have aluminum sulfate and water. If you take a look at this, basically what is occurring here is that you have aluminum, and it's kind of hard to see, but water, actually you could write it in a way to where there is a cation and an anion. You know, you could write it as a hydrogen ion and a hydroxide anion. Notice then you have H2O, it's still 2 hydrogens and an oxygen, but maybe it's a little easier in this way for you to see that maybe the cation, the aluminum from the aluminum sulfate, could react with the hydroxide, forming aluminum hydroxide. And then what's left over, you have the cation of the second compound, the hydrogen from the water, combining with sulfate to form the sulfuric acid. So this is, in actuality, a double replacement reaction. In this problem, okay, I'll notice that I have an organic molecule. How do I know it's an organic molecule? It's a hydrocarbon. It contains carbon and hydrogen. This is actually a carbohydrate because if you notice you have carbon atoms, 6 carbon atoms attached to what are essentially 5 water molecules. It's really a sugar. When I combine this with oxygen, it's going to yield carbon dioxide and water. So if we're going to go ahead and balance this, let's do the atom inventory. There are 6 carbons, there are 10 hydrogens, and there are 5 plus 2, there are 7 oxygens. On the product side, let's see, 1 carbon, 2 hydrogen, and 3 oxygens. All right, let's go ahead, and if I put a coefficient of 6 here, that's going to make 6 carbons, 12, 2 times 6 is 12, plus that 1, I now have 13 oxygens. Let's look at the hydrogen. I have 10 and I have 2. Well, if I put a 5 in front of the water, that's going to make this 10. And now for the oxygen, I have the 2 times 6 is 12, plus 5, which is going to give me 17. All right, everything's balanced with the exception of the oxygen. All right, 7 and 17, those aren't going to be fun numbers to factor. But if you notice, okay, I have these 5 oxygen that are over here, and these 2 are separate. So basically what I can do, all right, I know that if I take 5 away from this 17, that means I have to come up with 12 out of this oxygen here. That makes the problem a lot simpler. So if I can put a coefficient of 6 here, 6 times 2 is 12, plus those 5, there's your 17. There's the balanced formula equation. Anytime you have a hydrocarbon combining with oxygen and the products are carbon dioxide and water, this is going to be a combustion reaction. This is a complex combustion. Okay, this problem, it looks like we have nickel 2 chlorate turning into nickel 2 chloride and oxygen. All right, let's take a look here. Atom inventory. There is 1 nickel. There are a total of 2 chlorines and there are 6 oxygens. On the product side, there is 1 nickel. There are 2 chlorines and there are 2 oxygens. And so the only thing I had to do to balance this one, if I put a coefficient of 3 here, this becomes 6 and it is now balanced. Okay, you will notice in this case I have 1 compound that is breaking apart and forming 2 products. That is indicative of a decomposition. That is a decomposition reaction. Okay, in this reaction I have aluminum nitrate reacting with sulfuric acid, forming aluminum sulfate and nitric acid. Let's do our atom inventory. And so let's see, I have 1 aluminum, nitrogen I have 3, oxygen I have 3 times 3 is 9, plus those 4 is 13 oxygens. 2 hydrogen, 1 sulfur. I do the same thing for the product side. I have 2 aluminums. Nitrogen, it looks like only 1. Oxygen, I have 3 times 4 is 12 plus 3, that is 15. And let's see, hydrogen looks like only 1. Sulfur, there are 3. And so if I go ahead and start balancing, if I put a 2 here, that's going to make 2 aluminums. The nitrogen now, 2 times 3 is going to give me 6. The oxygen, 3 times 3 is 9 times 2 is 18. Plus those 4 should be 22 now. I've gone and made a mess of things. But that's okay, because we'll keep plugging and see what happens. Let's see, nitrogen, I have 6 and I have 1, so if I put a 6 here, let's see, hydrogen is now going to be 6, nitrogen is also 6, oxygen I have 3 times 6, which is 18, plus 3 times 4, 12, 18 and 12, that should be 30. Okay, let's take a look. 22 and 30 isn't going to be super fun. But what I can do, if I put a coefficient of 3 here for the hydrogen, that's going to fix the hydrogen problem, giving me 6. Sulfur is now 3. Oxygen, I have 3 times 4 is 12, and then 3 times 3 is 9 times 2 is 18, 12, and 18, 30. And we have balanced this formula. What type of reaction is this? Okay, once again, notice in the product we have the cation of the first combining with the anion of the second, forming aluminum sulfate, and then you had the hydrogen, the cation of the second one, combining with the anion of the first, forming your nitric acid. So this is a double replacement. Okay, on these problems, what you're going to do is you're going to take the word equation and turn it into a formula equation. So if you look at the first one, iron 2 sulfide, this tells me that the charge of iron is 2 plus. As you know, sulfide is just sulfur. It has a charge of 2 minus, so iron 2 sulfide is FeS. They are equal, they are opposite, they cancel. Hydrochloric acid, you don't know how to name acids yet or write their formulas, so it's just HCl. Hydrogen sulfide, okay, so you know hydrogen is 1 plus. Sulfide is just sulfur, it's 2 minus. So if you cross them, the formula for hydrogen sulfide is going to be H2S. And then iron 2 chloride, once again you have iron with 2 plus, chlorine is 1 minus. So the formula for iron 2 chloride is FeCl2. So this is the correct formula equation. Notice it's not balanced, but you have to write each compound as it actually exists. We'll fix the numbers with coefficients, with balancing. That's what fixes that portion. So now we're going to go ahead and balance this. Some of these you can do by sight. Like if you look at this, I know right away there's 2 chlorines and 2 hydrogens on the product side, and there's only 1 on the reactant side. So if I put a coefficient of 2 here, it balances it. You don't have to go through and do the atom inventory every time if this is something that you can look at and just do on your own. So there's the answer for number 7. Alright, on this problem we have sodium, which is just elemental sodium, plus water is going to yield sodium hydroxide. Sodium is 1 plus, hydroxide is OH, polyatomic is 1 minus, so it's NaOH. And then hydrogen is diatomic. You can't forget that little 2. Okay, that's one of those 7 special elements that are never found on their own. Now I need to go ahead and balance this one. You will notice that, let's see, 2 hydrogen, and then there's 3. Generally, you know, if I have 2 on one side and 3 and the 3 are separate, I generally like to go with a common factor of 4. So if I put a 2 in front of the sodium hydroxide, now I have four hydrogen, 2 oxygen. So if I put a 2 here, this will give me 4 hydrogen and 2 oxygen. Now all I need to do is balance the sodium, place a 2 in front of the sodium, and that is the balanced formula equation. Alright, copper 2 sulfate. So copper 2, that tells me the charge of copper is 2 plus in this instance, because it is a transition. Sulfate is a polyatomic ion. You've memorized SO4 2 minus, so the formula for copper 2 sulfate, equal and opposite, they cancel, it's CuSO4, plus ammonium sulfide. Ammonium is another polyatomic, has a 1 plus charge. Sulfide is just sulfur, it's S2 minus, so the formula for ammonium sulfide is NH4, and you must put that in parentheses, 2S. Okay, what products is it going to make? Copper 2 sulfide, so copper being 2 and sulfide being 2 minus, it's CuS, plus ammonium sulfate. Ammonium is NH4. Because sulfate is 2 minus, you got to put the parentheses 2, and then SO4, so that is ammonium sulfate. You will notice in this example, it's already balanced. This one came balanced. You don't have to do anything else to it. And that happens on occasion. Okay, in this problem you have aluminum bromide. You know aluminum is 3 plus. Bromide is 1 minus. So the formula for aluminum bromide is AlBr3. Reacts with chlorine. Chlorine has to be Cl2 because it is a diatomic, to form aluminum chloride, which is AlCl3. And then bromine. Bromine must be Br2 because, once again, it is also diatomic. And so in order to balance this, if I put a coefficient of 3 here and a coefficient of 2 there, that's going to balance my chlorines. And now to balance the aluminum, if I put a 2 there, I'd have to put a 3 there for the bromine. That is now the balanced formula equation. Okay, potassium chlorate. Potassium is 1 plus, chlorate is ClO3, and it's 1 minus. So the formula for potassium chlorate is KClO3, and then it says it's heated. A way to denote that a substance is being heated is you'll place a triangle above the arrow. Okay, anytime you see a triangle in chemistry, it means a change in something, and generally it's going to be the change in heat. And so if you write that above the yield sign, that means heat must be added in order for this reaction to take place. Alright, so it yields potassium chloride, that's going to be KCl, and then oxygen gas. Oxygen being diatomic must be O2. Okay, let's look at this. In order to balance this, if I put a 2 here and a 3 here, the oxygens are balanced, then all I have to do is put a 2 in front of the potassium chloride. There is the balance formula. Alright, in this example, let's see, we have aluminum reacting with hydrochloric acid. You don't know how to name acids yet, but it's HCl. It produces aluminum chloride, aluminum being 3 plus and chloride being 1 minus. The formula is AlCl3. And then hydrogen being a diatomic has to be H2. Alright, let's take a look at this. If I put a 2, or no, excuse me, I need to have, looks like a common factor is going to be 6 for the chlorines. So I've got to put a 6 there, put a 2 in front of that. That's going to give me 6 chlorines on both sides. To fix the number of hydrogen, if I place a 3 here, and let's see, 2 aluminums. That should be a balanced formula for this reaction. Okay, these type of questions relate to your metal reactivity lab. Basically, as you recall, in order for this single replacement reaction to occur, in order for the silver to replace the calcium, silver would have to be more reactive. You'll be given a list of metal reactivities, and they go from the most reactive down to the least. And so in order for this reaction to take place, the metal that's going to be reacting with the compound must be more reactive than the metal found in that compound in order for it to replace it. So if you look in this example, I have silver attempting to react with calcium hydroxide. But because silver is lower on the list than calcium, this one is no reaction. RXN is just an abbreviation for reaction. Okay, and looking at this problem, Okay, this is another single replacement. Notice we have aluminum that's going to attempt to replace copper. Looking at the list, here is aluminum, here is copper. Aluminum is definitely above copper, so this reaction will take place. So we have to predict the products of this reaction. Well, aluminum is not going to bond with the copper. They're both positive cations. What the aluminum will combine with is the chloride anion. So one of the compounds is going to be aluminum chloride. Because aluminum is 3 plus and chlorine is 1 minus, the formula is AlCl3, and then the copper is given off just as metallic copper. Now in order to balance this, let's see, I would need a 2 here and a 3 here, so we have 6 chlorines on both sides, and I need a 2 aluminum and 3 copper. That is the balanced formula equation. Alright, in this example, okay, we've got calcium that's going to be trying to replace the chromium. The metal will replace the metal. And let's see, calcium, definitely higher than chromium since calcium is more reactive than chromium. This reaction will occur. Calcium is 2 plus. Chlorine is 1 minus, so the formula is CaCl2. And then the other product given off is going to be metallic chromium. And as you notice, this one is already balanced. We don't have to do anything else to it. Alright, in this example, you will notice that we have gold attempting to replace lithium in lithium oxide. Gold is the very least reactive of these metals. Lithium is extremely reactive. Gold is not going to replace lithium. Gold is sometimes known as one of the metals of antiquity. It's a metal that humans have known about for a long, long time. Why? Because it doesn't form a lot of compounds. Gold is found in what's known as a native state. It's found in its free, uncombined form. You can take gold, bury it out in your yard, go dig it up in a couple 100 years. Guess what? It's still going to look like gold. It's still going to be shiny and lustrous. The reason being, it's not super reactive. It doesn't even oxidize. So this one would be no reaction. And that's all you have to put. Alright, on this last set, you were to complete the word equation, write the balanced formula equation, and identify the type of the reaction. Okay, so we have zinc and lead 2 nitrate. So zinc is just metallic zinc. Lead 2 nitrate tells me the charge of lead is 2 plus. We know nitrate is NO3 and it's 1 minus, so that's the formula for lead 2 nitrate. It's going to form, well, this is going to be a single replacement reaction. The zinc is going to replace the lead. And so zinc's charge is always 2 plus, and so you're going to end up with ZnNO3 2, and then metallic lead is the other product that is given off. And so let's just write, this is going to be zinc nitrate. You don't have to mention zinc 2 nitrate because zinc is always 2 plus lead. Alright, and already balanced. What type of reaction is this? This is a single replacement. Alright, in this problem we have barium chloride. Barium is 2 plus, chlorine is 1 minus, so the formula is BaCl2. Ammonium sulfate, ammonium is 1 plus, sulfate is 2 minus, so the 2 comes down. That's the formula for ammonium sulfate. What's going to happen is that you're going to have the cation of the first, which is barium, combining with the anion of the second, which is sulfate. Because they're both 2 plus and 2 minus, they're equal and opposite, they cancel. Barium sulfate, and what's left over is ammonium and chloride. You must write the cation first. Ammonium chloride. Alright, then all you would have to do to balance this is if you place a 2 in front of the ammonium chloride, then everything happens to be balanced. So let's write the word equation here. So this is barium sulfate. I'm running out of room and I'll put plus ammonium chloride. This one happens to be a double replacement reaction. Alright, we have magnesium chloride. Magnesium is 2 plus, chlorine is 1 minus, so the formula is MgCl2. Plus potassium phosphate, potassium is 1 plus, Phosphate is PO4, and it's 3 minus, so the 3 comes down there, so potassium phosphate is K3PO4. It's going to turn into, the magnesium is going to go with the phosphate, so magnesium, there's the 3 from the phosphate, PO4, there's the 2 from the magnesium, plus KCl, potassium chloride is the other thing that is made. So as far as balancing goes, if I would place a 3 here, let's see, and I'd place a 2 here, and I would need a 6 here, and that would be the balanced formula equation for this reaction. As far as words go, I'll maybe write them down here so I have room. Magnesium phosphate plus potassium chloride. Alright, so there's your balanced formula equation. This one is a double replacement reaction. You have the cation of the first one reacting with the anion of the second, and vice versa. Alright, this one you can tell is going to be a decomposition because it has the word decomposes there for you. Some key concepts you need to recall for decomposition. If it's a simple decomposition, basically what's going to happen is that the compound is just going to break up into the 2 elements that it's made out of. That's going to be the easiest one. If you have some metal that combines with a carbonate, polyatomic carbonate, which is CO3, 2 minus, generally they're going to make a metal oxide, so metal combined with oxygen from whatever metal is present, and then the other product is going to be carbon dioxide. If you happen to have a metallic hydroxide, so a metal attached to an OH, they're generally going to make the same type of metallic oxide, so the metal is present combined with oxygen, and then the other product is going to be water. If you have a metallic chlorate, chlorate is ClO3, 1 minus polyatomic ion, generally they're going to make a metallic chloride, so the metal with chlorine, and then give off oxygen. Fortunately for this one, this is just a simple decomp. You just have silver oxide, and so silver is always 1 plus, oxygen's 2 minus, so the formula for silver oxide is Ag2O. And what it's going to turn into, it's going to turn into silver metal and oxygen gas. Okay, now to balance this, I need to put a 2 in front of the silver oxide to satisfy the 2 oxygens, and then put a 4 in front of the silver. And so we'll just say it turns into silver plus oxygen. And this is a decomposition.